Hello learners, I, Dr. Abha Sharma, welcomes you to the Nios Studios. Today we are going to discuss about process of scientific inquiry, engaging learners in scientific processes. The presentation is sequenced as follows: process of scientific inquiry, engaging learners in scientific processes, developing capabilities, raising questions for inquiry, hypothesizing to get directions, and major steps involved in the development of hypothesis. The process of scientific inquiry, basically all the processes in sciences are done with specific purpose. Evidences are collected with reliable and valid methods, and they are examined critically by controlling different variables. Scientific inquiry is a holistic process, and to be scientific, any process needs to follow certain rules, certain steps specific to that discipline. These processes are not natural to human beings, and therefore one needs to learn them systematically and with a focused attention. As learners go through many cycles of learning, experiencing scientific inquiry, they acquire higher level of expertise by doing concerned processes. Development of all these skills involves use of all language skills such as active listening, asking questions and queries, narrating and describing observations, write the explanations, search for appropriate words and phrases, coin new words in case if they are required. Now, the different processes that are involved in scientific inquiry consist of observing the patterns and wondering about objects, events, phenomena, experiencing and sensing discrepancies and dissonance, becoming curious and uncomfortable, reflecting on various decisions and processes, aiming for better and contextually appropriate solutions, doing thought experiments, assessing personal development, along with that deciding purpose, asking answerable questions, refining questions, hypothesizing, predicting, sharing and presenting ideas, talking to others, receiving feedback, listening actively, arguing, planning, visualizing and designing for collecting evidences, for testing evidence, considering variables, defining ideas, measuring, making sense of the data, analyzing and transforming the data, inferring, reporting, finding, evaluating the processes and products, assembling apparatus, conducting experiments, designing workable models, gathering and documenting data, and collecting information from various resources. Engaging learners in scientific process. Inviting younger children to engage into scientific exploration is the major task of the facilitator. As facilitator, you are responsible for promoting cultural and scientific inquiry. The order of presenting information is as follows. First of all, the description of some critical attributes of the particular process we have to do. Then, type of assistance needed by the learner to acquire these skills required to conduct these processes. Some of the objective specifications that we can keep in mind for organizing learning experiences, and finally, some examples of the tasks that might help facilitators in inviting learners to engage in a particular process. These tasks basically demand the learners to develop a product that can be used for evaluating performance of the learners. Please remember that learners will be using their abilities in order to complete tasks given or the task in which they are interested. In that process, they will develop capabilities related with different skills with higher level expertise. Engage learners in various scientific processes and different thinking processes such as inductive and deductive thinking, critical thinking, etc. They are required for conducting scientific inquiry. The deductive thinking basically moves from the information to the theory, whereas the inductive thinking moves from theory to the confirmation. Developing capabilities basically enhances the consciousness, it increases the systematicity, more of the quantities, more of the focus, more meticulous, and it shows difference for using logical mathematical intelligence. It increases the rigorousness and it exhibits the scientific temperament. Raising questions for inquiry. The young children keep on asking many types of questions when they are allowed to do so. These questions are resulted out of sheer curiosity about certain things, wonderment experienced due to certain situations or events, experiencing a discrepancy or a dissonance, etc. All these questions are not investigable. For this reason, we need to assist children to ask questions that serve as starting point of inquiry. The questions may seek for information, a verification of information, a cause and effect relation, an explanation or an idea. Let's do one activity. The process of inquiry depends on the kind of question an inquirer asks. Look at the following list of questions. Analyze each question for specifying degree of inquiry it demands for. Now, there are many balls here. One is a football, one is a cricket ball, one is a tennis ball, and one is a basketball, as you can see. Now, out of all these balls, which of the balls bounces highest? Is the ball better than the other one? Is the ball better for playing cricket? Now, we move on to another activity. Why most of the plants have green foliage? How plants having leaves with different color make their food? Why do I experience headache whenever I try to enjoy sweets? Why most of the animals have red blood cells to help oxygen exchange? Why am I not sinking in water while I am swimming? Is my density become less than that of water? What did Archimedes experience when he entered into water bath that has relevance with his problem? How you analyze these questions to decide whether they are investigable or not? Don't you think that analyzing these questions is itself an act of inquiry? If your answer is yes, then raise questions that will help you complete this activity. I'll give you some tips for analyzing inquiry questions listed above. Here is a suggestive list of questions. Is it possible to decide the grade of the quality in question by measuring it? Is it possible to list dependent and independent variables that affects quality of questions? Is it possible to control variables that affect the quality in questions? Is it possible to collect reliable and valid data by designing and executing an experiment? Does this question make it possible to verify the cause and effect relation in question? And our goal of developing capabilities of raising question involves assisting children to become aware of the fact that only some questions help us to conduct inquiry empirically, that is, by conducting experiments or by collecting information from archaic material, historical artifacts, and archaeological material or other resources. They should feel the need of change, why and how type questions into investigable questions and work accordingly. Now, what is important is the role of the facilitator. So, the facilitator need to help children to be aware of the possibility of inquiry related to their own questions, be able to pose investigable questions to satisfy their curiosity, clarify their questions to others for helping them to search for the ways of finding the answers, raise questions while they are reading information by observing a situation or an object. This understanding of process of raising questions leading to inquiry helps you to identify some specific objectives. The objectives are as follows. The learners will be able to ask questions leading to the particular investigation and ask questions based on the hypothesis. Identify questions that they can answer by the investigation and devising questions in the form that helps in conducting investigation, etc. Learners' capability to raise questions can be developed by asking them to design sample questions in a given situation. Remember that we need to design situations that are not based on the information that they already have. The situation should be unfamiliar to them. This situation should motivate them to be curious and raise investigable questions. We will deal with one sample task, that is, after visiting a temple in a nearby town, students were asked to raise questions that intrigued them. Deepu raised the following question: why all temples have cylindrical columns? Is this question investigable? If yes, explain how. If no, explain why. Suggest a question that helps her to conduct an inquiry. Shibu is interested in knowing which color absorbs more heat. Please help her to design a set of possible at least 2 investigable questions. Help Salma to select questions that are leading to inquiry by encircling their numbers. Why all natural celestial bodies are spherical in shape? Are all natural celestial bodies spherical in shape? Are there celestial bodies that have shape other than a sphere? Are all bodies that move around their own axis have spherical shape? Hypothesizing to get directions. On the basis of your prior understanding and assumptions, you try to explain the data or the observations you have gathered. These explanation is called hypothesis. Here you are using your knowledge or concepts as tool for understanding the situation. But to be specific and scientific, a hypothesis must satisfy 2 conditions. First condition is that it should be consistent with the evidence. Second condition is that it should be testable by supporting it with relevant data. For example, you observe that a piece of pith of an old tamarind tree log sinks in the water. On the basis of your observation and previous knowledge, you can hypothesize that the density of tamarind wood is more than that of water. If all pieces of tamarind wood sink in water, then your hypothesis is consistent with evidence. If a piece of particular part of the log sinks in water but not all, then your hypothesis is not consistent with the evidence. For testing this hypothesis, you can collect data by sinking pieces of tamarind log of same size, same weight from different trees and sampled from different parts of the logs. To be testable a hypothesis, there should be a possibility of collecting evidence. There is some invisible and undetectable force in tamarind wood that forces it to sink in the water is untestable hypothesis. There is no possibility of collection of data to test this hypothesis. Behavior of any object depends on many variables at a given instance. For studying water retaining capacity of soil, you need to test it on the basis of size of the particle, percentage of humus, its absorption capacity, etc. By conducting investigation to test these variables, it is possible that all hypotheses might get eliminated. If some hypotheses do not get eliminated, there is every possibility that further evidence might disprove it. Again, one must keep in mind that any sound and reliable evidence that disapproves it, it is sufficient to reject it. That is why any scientific knowledge is always accepted as tentative truth and not as eternal truth. This is one of the important characteristics of hypothesis. These also give you a rationale for assisting children to experience process of scientific inquiry. The major steps involved in the development of a hypothesis includes: step 1. For developing a hypothesis, one needs to identify characteristics of an object, event or phenomena that is relevant for giving an explanation. Step 2. Then one needs to connect it with some relevant idea that you experienced previously. Here, one should insist on giving cause and effect relationship between the two variables. Younger children, due to their limited experiences, come up with many impossible explanations. Facilitators need to assist learners to make an effort to use some idea or concept for explaining the observation or relationship. Use concepts or ideas acquired in one situation to explain other situation. Put forward many explanations that are possible with respect to one situation. Put forward an explanation that is verifiable. Suggest testable explanation, though they feel that it is not correct one. By now, you are in a position to list some of the specific objectives related to process of hypothesizing. Learners will be able to explain the situation in terms of familiar concept of information, develop more than one explanation and judge the testability of given explanation, etc. Sample tasks. Here are some sample tasks that are designed for inviting learners to use their abilities to develop hypotheses. Task 1. Monu and her friends are walking to the school. There are many trees growing along the side of road. They've observed that there were nests of weaver birds only on some variety of trees. They are now puzzled. Please suggest two explanations for this that can be tested by collecting relevant data. Task 2. Amit's house is surrounded by trees and flower bushes. He observed that flower bushes growing under the trees are taller than those growing in the open. He came up with the following hypothesis. Bushes growing under the tree don't get bitten by heavy rains. Bushes growing under tree are getting fertilizer that is given to the trees. The soil under trees contain more composite due to rotting of the tree leaves, and bushes under the trees grow tall as some force present in trees force bushes to grow. So students, we have discussed today about the process of scientific inquiry, engaging learners in scientific processes, developing capabilities, raising questions for inquiry, hypothesizing to get directions, and major steps involved in the development of hypothesis. Thank you so much for listening.